All right. We are at 15 minutes to 3, which is the exact time we want to be for having 15 minutes of questions and answers. And just know that you have to ask me simple questions, otherwise I'll just hand them over.
I was keen in on the fact that we could look at a single subject using the time series n equals 1. It just seems a simple extension to be able to do a multiple baseline kind of study that the behaviorists used to do, where you would put in a phase of treatment, so you create another variable that was a phase of treatment, and be able to look at the intervention effects on individual subjects that are time embedded.
So like an A-B, this kind of design?
Something like, well, except you observe one subject and then introduce an intervention, then the second one is later introduced, and then the intervention timing is...
that kind of wedge?
Wedge, yes.
Yeah, right. I think there are nice unexplored possibilities in the n equals 1 or repeated n equals 1 type of analysis, definitely. You should not overlook the n equals 1 in favor of two-level analysis, certainly. There's a lot there. And there's some interesting articles that I'm going to point to in that n equals 1 area when we get to the afternoon. All right, thank you. More questions? Yes.
We've been talking a lot about the latent centering, and in the most recent example, I believe with the define command you were doing observed centering.
Oh yeah, good question.
Was there a reason
I meant
for
to
that?
actually make that distinction. Here is the observed centering of negative affect, which is the predictor down here, you know. If you look at that picture, maybe that's easier. The latent variable centering refers to the dependent variable up here. If we do a standard analysis here of urge on negative affect, you can see that as just a standard random slope analysis where you do a group mean centering as recommended. So that's for the observed variable. Was that your question?
I guess I'm just trying to understand the logic of how you made that decision there.
Okay, yeah. Actually, there are two things conflated here. I started with a model that did not have this effect, did not have that effect. And in that case, it's clear that here you have a time series model, and you do the latent centering here, the implicit latent variable centering. Here you have a standard at the same time regression, and the regular rules for doing centering on the observed variables hold. Now I complicated the model, and maybe I put myself in jeopardy here by having a time series for negative affect as well, in which case, since we do that as a latent variable centering as well for negative affect, right?
No, I think it's the same thing that Alan was talking about earlier, is that we actually don't have that feature there.
Can you take a microphone for?
So basically, that is the same issue that Alan was talking about. So when we have
repeat it for the group, so we can.
So if you have y1 on y2, so the centering that's available when it's resolved is when you have y1. Y on y at 1, right? In that case, you don't have to do observed centering.
When you say y on y at 1, you mean y
ampersand.
on y ampersand 1, right?
Yeah, that's what I meant, yeah. So in that case, the centering is automatic.
Right.
But if you have a path analysis like you do here, then that feature actually isn't available. So it's available if you have non-random slopes, but in version 8, it's not available for random slopes.
Oh, okay.
Right, so this is where I think that's what he was asking about.
So here, okay, good reminder. So here, the latent variable decomposition of negaf is not done because it's done because negaf has a random slope pre-multiplying it. Is that correct? He's scratching his head.
I think the question was about why negative effect is observed centered. And the reason it's observed-centered is because we don't have, if that the random slope SYX
Right.
is random, then we just don't have it right now. It's just one of the features that are left out. So we'll
This was
fill
what I
in the
reminded
holes.
Ellen about, right?
Right, that's the same
And then
issue.
I put it aside and didn't see it in this context. Yes, okay. So yes, exactly. And it may change and may become available in the next version. So to repeat, when you have a random slope like this, negative affect does not latent variable decomposition is not done for negative affect, despite the fact that we do a lagged regression. So the latent variable decomposition is only done for this variable, right?
That's correct.
But then somebody can argue, well, you have a random slope there too. I'm just trying to make it.
Well, that's, it's kind of, I think you guys didn't, well, anyway, so it's available for that case, right? For that case, it's available, right?
Right?
It's when it's not available, it's when the relationship between the two variables is of lag 0.
So it's not available when the relationship between two variables have lag 0, the contemporaneous or concurrent regression.
Right.
All right. I can see a whole set of pedagogical papers here.
Well, you guys didn't complain early enough about it. That's what.
That's exactly right, because we were learning as we go along here, and when you start teaching about it, you start thinking, oh, wait a minute, that's when you really learn the depths of this. All right, so did you survive that? Yeah.
There's one right there.
All right, good.
Hi there, thank you. So this is just to make sure that I understand, and hopefully others are in the same boat, or at least could benefit from this question. On slide 39.
39.
Where you present your time scores across
Could
a
you
24
speak a little louder?
Sure, where you present your time scores across a 24-hour period.
Right.
I guess it's two questions. So one, Mplus can handle the first time score not being centered at 0. So for example, if this was real data, the first input for this individual could be 0.32. Is that correct?
Right.
Great. And
Like it is here, yeah. This is actually from the smoking data.
okay. Terrific. And then the next question, if we go forward and go into the next day, so new time 10, and we're going by 2 hours, it would be something in the ballpark of observed time 1.01?
Exactly, 1 point something for the next day, yeah.
Okay, and so forth
Yeah,
until the end.
exactly.
Thank you.
Thank you for asking that question.
So back to the previous set of slides. So the presently is it
Could you hold
only-
your mic a little
Oh, sorry.
closer so you get it well recorded?
Is it only are you only capable of doing directional auto regressions? So in other words, would it be possible to say like to combine that ampersand with a with statement, so that if I don't have to posit a directional relationship on the x side, on the NA side?
Or here you mean?
Yeah. No, flip to the next slide, please.
Oh, okay.
So right there, you drew a directional arrow there, right?
Here?
Right. So what if I'm not willing to, make that assumption that there's a causal relationship there?
Then you shouldn't say anything about this part, because then it will be automatically done as with behind the scenes in a sense. But like regression, you don't estimate those parameters. So they are freely correlated. Say
Okay,
nothing.
thank you.
Hold on a second. Hold on a second. We want your wisdom recorded, Tiemer.
So the reason this is done, that relationship is there, is because of there's missing data on that variable. So having that arrow there would imply that you get much better imputations for these missing values.
Right.
So I would, that's how Ben had it, and I was pushing him to actually add that in there because it should improve the estimation. I don't think it actually made any difference, but
No, I didn't.
in this
but-
example.
But in principle,
this push.
we have a lot of missing or some missing data on this variable, and to not deplete our sample size, to throw away people, like we did yesterday, at the very end of the day, we bring this variable into the model by that regression, and then we can use everybody. If they have missing data on NA but not missing data on urge, they get to participate in the estimation. Yeah.
I have two related questions about the T intervals. One is if there's more than one data point in a bin, how are those handled? And
If there are
then-
more than one data point in the bin, we do so-called flattening. And Tiamer is going to explain exactly what that means tomorrow morning.
Yeah.
I'm glad you're interested.
And then the second related question is if it's not clear exactly what intervals I should use for the bins, is there a way to try a couple of different kinds of binning, and will Mplus generate statistics to allow me to compare which one looks best?
Yeah, so you can change this. This setting can be changed 0.8, 0.04. You can vary that and see how sensitive the results are to that. And of course, it corresponds to 2-hour differences versus 1-hour differences. So substantively, it changes as well. And yeah, we have actually started conversations this week between Tiamer and Tui, our front-end programmer, to provide a plot that compares the real time with the time that we assess to show how closely related they are. So if they're not closely enough related, you may want to adjust the T interval setting to something different. Okay.
But yeah, the answer is there's no statistical tool that will actually determine that number.
Right, no
There's
statistical tool.
I'm interested in the ability to predict the residual variance now. So I think that was in the last model where you were predicting.
Here?
Yeah.
Oh, yeah, right. Like here.
Yes. So I'm thinking about how to interpret that. Is it that for females, the spread of the variance is actually larger than it is for males? Is that how we should be thinking about it?
Mm-hmm.
Okay. And can you use, it's only possible to use between level variables to make that prediction?
Well, that's a good question. So you want to have a potential predictor of variance on within. That's the chapter 1 in the book. You can actually let the residual variance in the regression be a function of an observed variable using model constraint. Tiamer looks like, what is he talking about? But that is, you model heterogeneity in the regression, that is, the residual variance varies as a function of the x value, for instance. That would be a within level matter. Do you want to add to that, Tiamer?
I'm not sure if I understood the question completely, but you can, the log variance of v, right? That's a latent variable on the between level, and you can put it anywhere you want, any structural equation. So,
but he wants the residual variance to be a function of a within level predictor here somewhere, like a time varying covariate, like maybe negative affect influencing that.
like in time, like in cross-classified modeling, sort of. So that's another one of these features that's not available. So the log variance is a random effect so it can vary across individuals, but not across time.
Yeah. Okay. Yeah, that's one fact. Yeah. So what can vary across time is intercepts and the autoregressive coefficients, but not the residual variance, not the log v. Log v can vary across subjects, as can intercept and the slope as well, of course.
Again, this is not, if we, 8.1 might actually have that feature. So
we're thinking
It's not
version
impossible.
8.1 here. There are lots of little development or big development that we're excited about. But don't ask us when it will come out.